Hello, my name is Stephen Gottlieb, and I made the SAT subject math video. At this point, I would just love for you to sit back and view a sample demonstration. How about we get right into it? I'll show you how to simplify a radical. Suppose you have the following problem. The third root of 135 times x to the 5 y to the 3. The hardest part of this problem will be dealing with the 135. We want to write it like x to the 5th y cubed, except we'll know what x and y is. That is, we want the prime factorization of 135. Now, depending upon how strong you are, you might say 135 is 27 times 5 and 27 is 3 cubed. And that's the prime factorization. 3 cubed times 5. If you need to, you can use the factor tree. 5 goes into every number that ends in a 5. So 5 goes in there. How many times does 5 go into 135? Well, 5 goes into 5 goes into 13 2 times. 2 times 5 is 10. Take that away from the 13. You have 3 left over, and 5 goes right into 35 7 times. So 5 times 27. 5 times 27 equals that number. The number on top. So 5 times 27, or 5 times anything that equals 27, multiplies out to 35. But 3 times 9 is 27. So 5 times 3 times 9 is 27, is 135. In fact, 5 times 3 times any way you write 9 is 135. And 9, of course, is 3 times 3. These n numbers are prime. That is 5 times 3 times 3 times 3 is 135. 5 to the 1 is only 1 5 times 3 cubed. Okay, so that was the hardest part of this problem. I'm now going to say that this is equal to the cube root of 135, which is 5 to the 1. Let me not put an x there. Times 3 cubed times x to the 5th times y cubed. Now the rest of the problem is very straightforward. It's just long division. We're going to divide 3 into 1, and 3 into 3, and 3 into 5, and 3 into 3. But first we identify the bases. 5, 3, x, y. We write this down 2 times. The second time underneath the cube root sign. If that was a 5, I'd put a 5 here. By the way, when we do the long division, if this were 13, I would divide 13 into the powers. So I put the bases under the cube root sign as well. 5, 3, x, y. And then we do long division. 3 into 1. 3 into 1 goes 0 times. 0 times 3 is 0. You subtract, you get the remainder. 0, remainder 1. The 0 goes here, and the remainder goes under the radical. The 1 came from the 5. Notice where I put the 0 and the 1. I put them by the powers of 5, by the base 5. Now we do 3 into 3. 3 goes into 3 one time. 1 times 3 is 3. We subtract, we get no remainder. Okay? 1, remainder 0. Now we do 3 into 5. It's just long division. Pretty neat. Okay, 3 into 5. 3 into 5 goes one time. 1 times 3 is 3. You subtract, you get the remainder. 2. 1, 2. It's easy as 1, 2. Now we do 3 and 2. I'd rather it not be 3. Let's make this 7 instead, please. Actually, let's make it 9. Okay, so now we do 3 into 9. Three into 9. It goes 3 times. 3 times 3 is 9. You subtract, you get the remainder 0. So I put 3, remainder 0. Now, there's a good chance or a possible chance that this problem is now finished. If you don't have powers of 0 or 1, the problem is outright finished. But some of our powers happen to be 0 and 1. Zeros and 1s. Well, 5 to the 0 is 1. And whatever this turns out to be, 1 times this is just this. That is, you don't need this 1. And 5 to the 1 times x squared times 1, you don't need the 1s. Okay, next comment. If the power is 1, you just get the base. 3 to the 1 is 3. X to the 1 is x. Y cubed, times the cube root of 5 to the 1 is 5, times x squared. The hardest part of this problem was breaking down the 35. That was the 135. That was step 1. Step 2 is to do the long division and then write down your answers. 3 goes into 1, 0 times remainder 1. 3 goes into 3, 1 time, remainder 0. 3 into 5, 1 time, remainder 2. Do the same with the 9. And then, last step is when you have a number to the 0 power, remember, y is just a placeholder for a number. When you raise it to the 0 power, as long as y is not 0, you get 1. And when the powers are 1, you just write the base down. You just write the base down. That's the answer. Okay, now a good thing to go over is to talk about why this works. Now the first thing I want to do is put the answer higher up. That way I have more board space. And then we'll go over why this works. So this is equal to 3x y cubed times the cube root of 5x squared. Okay, confirm I copied it down right. Now, couple of things we have to review. If you have the cube root or the nth root, n can be any number, times a times b times c times d, you can even have powers, 3, 4, 2. This is the nth root of a cubed times the nth root of b to the 4th, etc. You can take the nth root of each of these 4 factors separately and then multiply the results together. And we're not going to prove that today. So we have that. The other thing I want to talk about is if you have x cubed times x squared, most everyone knows the answer is going to be x to some power. Some students say you multiply the powers. Others might say you add the powers. Some might say, you know what, you do one or the other. I keep forgetting. Well, it's not that hard to figure out what's going on. You must know what x cubed means. It means that times x squared. Oh, we're multiplying 5 x's together. 3 plus 2 is 5. You want to go 1, 2, 3, 4, 5, go for it. but it's still 3 plus 2. You have 3 here and 2 there. You have 5 altogether. You add the exponents. Another way of figuring that out is x to the 1 times x to the 1. Most students know that x to the 1 is just x. X times x. And these same students know that x times x is x squared. Okay, well, just ask yourself, is 1 plus 1 2, or is 1 times 1 2? And 1 times 1 is 1, so you don't multiply. But 1 plus 1 is 2. I do want to point this out, please. Don't do it with this x squared and x squared. Because if you add the exponents, you get x to the 4th. If you multiply the exponents, well, let me say it again. If you add the exponents, you get 4. If you multiply the exponents, you get 4. So in other words, if you say, well, if we use this method up here, if you say, well, that's x squared times another x squared, 1, 2, 3, 4, or 2 plus 2 is 4, and you say, oh, yeah, I was right. You multiply the exponents, because 2 times 2 is 4. Fair enough, but you should add them. So don't do it this last way. The next thing I want to talk about is exactly what does it mean to take the cube root of something. What does it mean to take the cube root of whatever that is? Well, this is asking a question. What do you multiply by itself 3 times to give me that? What do you multiply, what one thing do you multiply by itself 3 times to give me this? Now, if this is 2 cubed, which, by the way, 2 cubed is 2 times 2 times 2. This is asking a rather simple question. What do you multiply by itself 3 times to get this? And the answer is 2. I know I'm right. I know I'm right. Because when I take my answer and multiply it by itself 3 times, I get that. I really do get that. Or if you prefer this. What do you multiply by itself 3 times to give you 2 cubed? 2. There's nothing special about 2. If these were 12s instead, what do you multiply by itself 3 times to get 12 times 12 times 12? 12! And if you had 13 here instead, what do you multiply by itself 13 times to give you 12 to the 13? 12! If you multiply 12 by itself 13 times, by definition, you get 12 to the 13. So we get 12. So no matter what the no matter what the root is, it's asking, what do you multiply by yourself n times to get this? Alright, now let's look at this problem again. And let's see why long division works. You should never accept any rule that your teacher tells you without understanding it. You have to understand it. Now, 135 we realized was 3 cubed times 5 to the 1 times x to the 5th times y to the 9th. Now, every time I have something to the third, when I have a factor that's something to the third power, I just get the base. That is, if I have 17 to the third and I want the cube root of it, I just get 17. If I have the cube root of y to the third, get back y. Why is that true? Because when I multiply that by itself 3 times, I get y cubed. This is asking, what times itself 3 times gives you y cubed? Stop taking this nonsense that your teacher might say those things cancel out, or you can cross them out. Why? Why can you cross them out? Because your teacher said so? No. By definition. Okay. So, This mess is equal to the cube root of 3 cubed times the cube root of 5 to the 1 times the cube root of x to the 5th times the cube root of y to the 9th. Now I'm not saying you need to write this, but this is a logic behind it. That power is 3, so that's good. No 3's go into 1, so that stays. But x to the 5th, that's x cubed times x squared. And y to the 9th, because 3 plus 2 is 5. Now y to the 9th is, well, 9 is 3 plus 3 plus 3. That is, this is y cubed, this is y cubed times y cubed times y cubed. When you add those powers, you get 9. Okay. A little bit more. This one I can break up to the cube root of x cubed times the cube root of x squared. And this I can break up into 3 cube roots. The cube root of y cubed times the cube root of that, which is y cubed, times the cube root of that, which is y cubed. This does not work if it's addition. If it was 3 cubed plus 5, it wouldn't work. Okay, now this I know is 3. This I don't know. The cube root of 5 to the 1. That's x. That's the cube root of x squared. This is y, this is y, this is y. Y times y times y is y cubed. Remember, we're multiplying this, this, and this. And if this is y, and this is y, and this is y, then we have y times y times y. Now, why didn't we end up with 3 y's? Or y cubed? Because 3 went into 9 3 times. So we have 3 times x times y cubed, which is 3xy cubed, times this times that. Well, let's just talk about that. If this line equals that line, that is, if you can separate these, like I did down here, well then you can put all of these together under one cube root sign. That is, if this equals that, then that equals this. As long as these are all cube root signs, and they are, and they're being multiplied, you can put down one cube root sign and multiply these 4 factors and put it underneath the cube root sign. Well, that's what I'm going to do here and here. This is 5. 5 to the 1 is 5 times x squared is 5x squared. And here is my answer. And hopefully it's exactly what I got before, and it sure looks that way. Just figure out how many times 3 goes into each of these powers. Put those numbers on the outside. So let's do it again. 3, 5, x, 9. I meant to say y. Underneath the cube root sign. 3 into 3 goes 1 time, remainder 0. 3 into 1 goes no times, remainder 1. 3 into 5 went 1 time, remainder 2. And 3 into 9 goes 3 times, remainder 0. These are history, and the powers of 1 you don't need. So there's your answer. 3xy cubed times the cube root of 5x squared. This completes the sample demonstration. Thank you for watching it to the very end. Most of all, good luck on your upcoming SAT subject exam. Thank you.